board. So the name of this unit is radicals. You guys have all seen radicals before, but you might not know that they were called radicals. So do you remember when we learned this symbol with a number underneath? You guys have all seen this, right? What do we usually call this? Yeah, we call it the square root. And what would this give you? What answer would this give you? It would give you the number 4. So basically, if you were to define what a square root symbol was, what would you say? If there's a number under the square root sign, what's sort of the general rule? You don't need to use math language, just use your own language. Sarah?
What number?
Exactly. So what number to the power of 2 is going to give you the number inside that little square root sign? Okay, so this is what you were introduced with when you were in grade 9 or maybe before, and we're going to dive a little bit deeper into this and do more things with it. One of the things we're going to do is, I don't know if you know this, but did you know there's actually a secret imaginary number written right over here? Now, do you know, so let me just explain it this way. You know when we write the letter X, what's the exponent in the X? Yeah, and what's the coefficient in front of the X? 1, right? So this is kind of like saying 1 times x to the power of 1. Do we write those ones? No, we don't. So they're there, but we don't actually write them. In the same way, every single little number that we're going to deal with will be a 2. However, when we get to something called the exponential unit, we're going to deal with numbers that are other than 2. But for now, you should know that when you have that little 2, it's really the square root. Let's give these official names so we don't have to keep calling them little number. That little number, n, is known as the index. And if there is no index written, we assume that n is equal to 2. So whenever you see that square root sign, the index is actually 2, we just don't write it. It's there, but it's not written. That little square root sign actually has a word or a term, and it's called a radical sign. And I never pronounce this correctly, but the number inside the radical sign is known as the radicand. You know, I've actually seen videos where it's pronounced in different ways. That's what it's supposed to be. And the official definition is the nth root of a number, a, can be written as the radical expression, index n, radical sign with a radicand of a. It's really complicated, but when we start doing questions, it'll make a little bit more sense. So before we start, let's talk about all the perfect squares up to 12. What's 1 squared? 1, yep. What's 2 squared? 3 squared. 4 squared. 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, and 12 squared, 144. Now, is there a chance that we might need to know squares greater than 12? Yes, possibly. Actually, I forgot to do this, but I'll actually print off a square chart for you that goes up to like 20 or 30, just for your reference. For today, we'll just sort of use our brains. If you have your multiplication table out, that might also help. But we're not just limited to the perfect squares up to 12. We will go a little bit higher. Now, another thing I forgot to mention is, you know, when we take the square root of a number, 4, or the square root of 16, there are actually 2 answers that we can get. What are the 2 answers? Leslie? Yeah, usually we put plus or minus 4. But what we're going to do is, for all of our examples, we're just going to look at the positive number. But we do know that under a square root sign, it could be positive or negative. But that's why I have that little note right there that says If a radical has more than one root, the radical sign indicates only the principal or positive root. So we're just going to look at the positive numbers. All right, so let's just get a little bit of practice. Go ahead and try questions 1, 2, 3, and 4, just to warm you guys up with square roots. And we're just going to be looking at the positive root. All right, what is the square root of 16? 4. What happens if you have a coefficient in the front? Well, that just means it's going to be 2 times the square root of 121, which is, yep, 11, which then multiplies to give you 22. Yep. I don't know if you guys got this from the multiplication table, but what is the square root of 289? Good, so this is just going to be 6 times 17. Was anyone able to multiply that? 102. And then there's the square root of 400. Yep, so it'll just be 3 times 20, which is equal to 60. Okay, so that's our knowledge from grade 9 and 10. Now let's go on to harder questions. We have a couple of rules. Rule number 1, find the largest perfect square that you can, and then break down the radical using this number. Take the square root of the perfect square, take it out of the radical, leave the leftover under the radical symbol. I also have a few other little definitions on the side. When simplifying radicals, we're converting an entire radical to a mixed radical. Entire radicals have a coefficient of 1, and mixed radicals have a coefficient other than 1. And I'll point that out as we do these questions. Okay, so we don't have a calculator. We're trying to figure out what the square root of 32 is. What we're going to do is we're going to break this radical up into smaller radicals. So can we think of 2 numbers that multiply to give us any 2 numbers? Yep, so we're going to break this up into root 8 times root 4. When I say break up, I mean simplify. Can we simplify? And our goal is to try to get a perfect square. So are any of these a perfect square already, Tanisha? Yeah, root 4 is a perfect square. So we're done. We don't have to break that down anymore. But how about root 8? Can we break that or simplify that any further, Sarah? Yeah, so I'm going to split that up again, and I'm going to write it as root 4 times root 2 times root 4. So essentially what I'm doing here is I'm taking my initial number, and then I'm finding factors of it. Then I'm taking another number and finding factors of it. And you want to keep doing this until you are left with a row of numbers that are either made up of perfect squares, like 4, 16, 25, or numbers that can't be broken down anymore, like root 2. You can't break root 2 down any further. Okay. This leads me to another really, really important rule. And the rule is when you have a matching pair of radicals, something really, really cool happens. Okay, so if I have something like root 4 times root 4, the simplification of that is it gives you just a whole number 4. And the rule is if you can find a pair of matching radicals, you can group them together and make them into a solid whole number. Why does this make sense? Well, let's see. What's root 4 equal to? 2. And what's root 4 equal to? Which is equal to 4. And this works for any pair of numbers. So for example, if I were to give you something like root 17 times root 17, this would simplify to give you just a whole number 17. So any 2 radicals that are identical simplify to give you a whole number of whatever the number was under the radical sign. Rosie? What would you break it down into? But then can you simplify that any further? No. So then you would just multiply it anyways, and then that would be your final answer. Okay. So what I'm going to do is I'm going to pair those root 4s together to give me a whole number 4. And I can't do anything with the root 2, so I'm just going to keep it, and I'm going to join it with the whole number 4. Okay, we can actually state a couple of definitions now. Let's take a look at them. The first radical that we had was called just an entire radical. So it's the entire thing. And what we have broken it down into is something called a mixed radical. So when you have, that's called a coefficient, just like when we had 4x, it was a coefficient. When we have a coefficient and a radical sign, it's known as a mixed radical. When we had root 32, it was an entire radical that we were trying to simplify. Okay, before we move on to another question, I want to show you just one other way to do this question. Let's just decide over here, and let's look at root 32 again. Can you split up or simplify root 32 into another two set of numbers that aren't 8 and 4? Noel? Yeah, let's say we pick 16 times 2. What's the square root of 16? By choosing those numbers, we actually end up getting the answer faster. Is there a proper way? No, there isn't. You can actually go any route that you want. However, you should always try to pick numbers that are perfect squares because it helps you get to the answer a lot faster. But either one of those is correct. And sometimes you'll find good numbers, sometimes you won't. I do find some of these numbers are really big, so we're going to pick more manageable ones. Let's go down to question number 9. Root 48. Can we think of two numbers that multiply to give us 48? Denisa? Sure. So we're going to go root 6 times root 8. None of these numbers are perfect squares, which means we need to keep going. What can we simplify root 6 to give us? Yep, so we're going to get root 3 times root 2. And root 8, what can we simplify that to give us? 2 and 4. So we're going to go times root 2 times root 4. If you're wondering, does the order matter of how you're writing things down? No, it doesn't. Every single radical is multiplied, and that's the most important part. Okay, now if you take a look at this, I can't simplify these numbers any further. I have a perfect square of root 4, which is perfect. That's what we want. And we also have a matching pair of radicals, which is another thing that we want. Okay, let's see why this is good. Can we do anything with the root 3? No, we can't break that down any further. Can't do anything to it, so I'm going to write that as is. What's root 2 times root 2? A whole number 2. So as long as you remember that rule, then that'll really help you. And what is square root 4 give us? 2. Now you can multiply coefficients together, but you can't multiply a coefficient and a radical together. So we can multiply the 2 and the 2 to give us a whole number 4. But then you can't multiply it with the root 3. That's your final answer for root 3. Does that example make sense? Okay, Ariane? Yep, you could have probably picked an easier number. Actually, I think the faster way is to do 16 times 3. So if you recognize that 16 times 3 is 48, then you would have gotten the answer right away. But really, there's no right or wrong. Like, as long as you're splitting it up nicely and you're coming to the right answer, that's all that matters. What are two numbers that give us 54? Nope, that's okay. There we go, good. So root 9 times root 6. We know root 9 is a perfect square, so that's great. Can we split up root 6 any further? Okay, so don't write this down, but let's say we did split up root 6 into root 3 and root 2. We know, thank you so much. We know the square root of 9 is a 3, so I can actually go ahead and replace the 9 with a 3. But now look what happens. I can multiply the 2 and the 3 together. Can I simplify root 3 and 2 any further? No, they're not perfect squares. They're not matching pairs. You can't do anything. So when you end up in a situation like this, the only thing you can do is just multiply them together, and your final answer would just be 6 root 6. So there may be situations where you have a radical that you can split up, but then nothing else can happen to it. You can't find a matching pair or anything like that. So in that case, you just multiply them together. This leads me to an important rule. You can multiply coefficients together and you can multiply radicals together, but you can't mix them up. Okay? So our final answer here, and now you can write it down that you understand it, would be 6 root 6. So I do want to try a question that has slightly larger numbers. Let's try question number 11, -5 root 150. So -5 is known as a coefficient. We're just going to keep it there. Let's think of a couple of numbers to multiply to give us 150. What are maybe the two easiest numbers? Tanisha? Yeah, I would probably pick those as well. So we're going to go 15 times 10. Neither of those are perfect squares. They don't match anything else, so we have to keep going. What can I split 15 into? So it's going to be root 5 times root 3. What can I split 10 into? Root 5 times root 2. Now, we still don't end up with any perfect squares. However, we do have a matching pair of numbers, so that's really good for us. The -5 is going to be here. What does root 5 times root 5 give us? Just a whole number 5. And then can we do root 3 and 2? We can't do anything, so what do we have to do, Sarah? Yeah, we're just going to have to multiply together to give us root 6. And so our final answer here is going to be -25 root 6. Okay, let's challenge ourselves and do question number 12. Now, if you're wondering what a possible strategy might be, you could look in your multiplication tables, or if it's an even number, you could just divide by 2 and go from there. However you want to try this. But can you guys tell me two numbers that multiply to give us 128? Bea? Is that right? Yep. Okay, so we have 16 times 8. Yep, that's right. And that is on your multiplication table, so as long as you have that, you should be good. 16 is a perfect square, so I am going to just change that to a whole number 4. Can I split root 8 up any further? Yeah, into root 4 times root 2. Question?
Is it possible to
Oh, it's if you simplify root 8 to root 4 and root 2, what will happen is root 4 is a perfect square, right? Yeah. So now what we're going to get is 8 times 4 times 2 times root 2. And this is just going to be 8 times 8, which is 64 root